For me, I think it's three bits to it. And I think, you agree, we've talked about this before.
Yeah.
There's really underpinning it all is the technology. So you have innovative technology. So that's, disruptive technology could be, any new thing that's coming along that can enable new stuff. Then there's design, which is how that technology gets applied to create new things.
Yeah.
And then there's the market aspect of it. And so that, there's the product market fit, there's the business strategy, and of course then the marketing. How do you actually get that to market, and why are people buying it? It's really important not to look at the status quo and say, well, we're going to improve on it a bit, because that's not disruptive design. You're not going to really change the needle. You're just fitting into the same picture. A really important one is if you're going to change stuff, it's going to get complicated. It's a bit like trying to piece together a big jigsaw puzzle without ever having seen the picture. So, you are kind of really having to try things out to see what starts to come.
Just sort of then diving in a little bit specifically, obviously we talked generically there about the disruptive innovation, but it'd be great to understand a little bit more about the rugby head guard.
When we started to get into it, so we started to really look at this area, and as you do, went back again to basics and go, well, what have we got to do? And what's the real problem here? How come it's no good us just doing a slightly better version of all the other ones? What actually needs to be done? And you start to realize very quickly this is even more complex than perhaps some of the other sports I've been looking at. There's schools involved. There's regulation.
Yeah, it's really tricky, isn't it? Because
Yeah.
I think as a set of stakeholder groups, it's very complicated, isn't it? I'd say especially with sports like rugby, which have obviously got the challenges in terms of the press and the media coverage, but actually those kind of challenges sit within other sports. But rugby's carrying a lot of the can, if you like.
Yeah.
But also they have a huge complexity within that sport of, it's played at professional level with sort of physicality that most of us would be scared of. But then right down through to grassroots where you've got young kids, and then you've got the complexity of parents, teachers, coaches, volunteer coaches that don't have a great deal of time and potentially experience that have to manage all this stuff. But they're doing that with a backdrop of, I guess, not having all the information at their fingertips as well, because the research and the science is still emerging, it's still forming, isn't it? So I see everybody wants to solve the challenge in the sense of that there is a great will to get to the destination.
Yep.
I guess the challenge is the destination is probably quite far away, and what do we do in the meantime?
Yeah.
And I think that's a really interesting kind of debate in terms of, obviously, when you want answers, quick answers to complex problems, it can take time.
Yeah.
Unfortunately, time is against us. So.
Spoke a lot to parents. We did a big survey actually of parents to understand even if what aspects of this they were really worried about, what they wanted from this. We talked a lot to players, and this is down to, okay, it's all very well saying, yeah, we can give you some padding on your head, but what does that really mean? And there's lots of things like sort of awareness. The hearing has a massive impact, as an example. So it's clear that actually, if you cut off some of that awareness, actually it's not as safe because people don't know what's coming. They need to know what's around them. So there's lots of stuff that builds up when you start to really question and understand the problems, and and then we end up looking to solve all that as a complete package. And then importantly, I think we're talking about the big puzzle. We built a design council of experts in concussion and regulation, and also the recovery.
I love the design council approach. Actually, I think something I often call it hypothesis testing. I think it's very easy to make a set of assumptions from someone that sits where you sit today.
Yeah.
But when you put yourself in 10 people's shoes and then you test the same logic, it's amazing how many different things you get back, isn't it? So I've done this because it's great for X, and then you find that 5 people think it's a negative because of Y, right? You're like, obviously you can never think about that until you get all those people in a room. So I think design council is a great way of really testing your innovation, because in order to be disruptive, you have to think outside the box. Yeah. But you can't think outside the box in isolation. You really got to bring that back and validate it with other people.
What's interesting with the design council, I think, is how when you get individual experts, you can have quite a skewed view.
Yes.
But I mean, it's the wisdom of the crowd, isn't it? It's when you get a room full of experts, you get an amazing level of knowledge, because then they all talk to each other, and actually between all of us, with all very different but high level and expert viewpoints on things, you suddenly start to get some really good insight and clarity and advice on stuff that you wouldn't if you talk to people individually. So it's quite useful as a group, I think.
We were talking earlier about the design and disruptive design process, sort of the fundamental tenets of design. Which bits of those do you think are most relevant and apply to the way you guys have developed the rugby headguard?
We took some quite smart choices, I think, around some of the materials we're using and how we constructed stuff so that we could do this really fast. and built some really good partnerships there with some manufacturers that were enabled us to iterate things quite quickly.
What is it about kind of this Hedkayse headguard that kind of offers a unique proposition from others out there already?
We clearly needed to have full all-round protection. You can't say you're never going to fall on the back of your head. So, you know, that's one of the reasons why. I've got one here, look. Yeah, there's one I prepared earlier. You know, this is why it's all the way around.
Yep.
Because you need this protection here just as much as here or anywhere else, you know.
So typically they have lacing at the back there.
Yeah, exactly. Which is, so, you know, obviously that introduces a problem, is how do you make it fit various sides, various shapes of head? Well, so that's why, you know, some of the construction is as it is, allows it to flex and change its own shapes. It solved a lot of those problems. It's comfortable. It stays on the head. It's got really good all-round perception because you can hear really well through it, which is great. We've got these areas here which are made of flexible material, so you get great hearing and the holes. We really started to then begin to understand there's actually a fundamental set of problems here, which I think we realized at the time the current products were not really as good as they could be.
Yeah, sure.
Partly because of this standard. So we started to really get that funny feeling where you really starting to want to step outside the status quo and, right, I've got to actually change this. This just needs to be better. So yeah, in questioning everything, we realized one of the things we're going to need to really understand was the materials, because if you're going to change this, you really got to understand what's going on with these things that can absorb energy. So we built our own test rig and tested, I think, about at least 100 different types of foam and stuff that we were, you know, banging, and we learned an awful lot from that. But we realized in that process there wasn't actually anything out there that was going to solve it. Fast forward 5 years, we'd done a whole load of material science and work on basically coming up with this new material, Enkayse, which is it started off as something a bit like memory foam, but it got heavily engineered over time, and we did an awful lot of development on it, and it became this very stable material that it gave us predictable performance across a wide temperature range. Actually, Imperial College has done some validation of the testing for us, and has shown that it's a 300G impact is reduced on average to 72.8G, which is
quite a remarkable reduction.
Quite a serious reduction.
What I think is really interesting, and going back to our comments earlier, is actually all of these things need to build up together. There's no one facet of that that's totally mature. As much as I'm sure Hedkayse isn't the magic bullet, and I'm sure you guys would say the same, is none of the solutions today are solving the problem. And in fact, no one solution can. Actually, it will all come together as part of a holistic approach. You know, it's been really interesting, Andrew. I think such a fascinating insight, and I'm really pleased with where you guys have got, and obviously delighted that we're able to share the journey together. And it's great that we can be so open with each other about the challenges, the opportunities, both from a design perspective, but from a product perspective, and a communication. I'd say a lot of this has got to come down to how do we engage people in this type of technology, what it does do, what it doesn't do, and how does it kind of be part of the overall solution. So that's really, really, really fascinating insight. Thank you very much.
That's all right. Well, thank you for coming and being part of the, inviting us to be part of the discussion. It is such an interesting area, obviously a real passion of ours as well. So let's just keep going and see where we can get to it with it.
Excellent. And